Hello everyone, I'm Céline Clauzel, geographer at the University of Paris Cité. I'm sorry I couldn't be there today, but I will be happy to answer your questions by email. Today I'm going to present you a research work on improving the permeability of highways. Wildlife crossings have become standard practices to reduce the barrier effect of major transport infrastructures. They improve connections between species habitats and thus biodiversity conservation. The location of the road section where habitat connectivity should be restored is often determined based on expert opinion and or landscape composition and configuration analysis. Considering habitat functional connectivity and not only structural connectivity is critical to the success of mitigation measures. Many studies relied on spatial modeling to consider functional connectivity to implement mitigation measures. These studies assumed that areas with high functional connectivity were those that potentially hosted the greatest flows of individuals. However, few of these studies tested the validity of this assumption with biological data, and the results were rarely confronted with opinions and knowledge of experts. However, integrating a field expertise is necessary to meet operational requirements that allows to confirm and or to adjust the large-scale recommendations based on ecological connectivity, considering the local context. We proposed here to address these issues by the following question: how to combine modeling and field approaches to reduce the barrier effects of major transport infrastructures. Our study was applied to the 1,800 kilometers highway network of northern France. We defined a methodological framework using graph theory, field expertise, and roadkill data to prioritize existing road structures to be improved, to find the best locations for new wildlife crossings, to make precise, costed technical recommendations on what needs to be done, and finally to compare the resulting locations with roadkill data. In the first step, we defined and grouped 9 species according to their habitat preferences. We modeled the ecological network of each of the 3 groups using graph theory and calculated several connectivity metrics combined in a multi-species approach. In the second step, we prioritized 1,000 existing road structures for improvement based on ecological functionality index, which combines 3 connectivity indicators: least cost corridors, the interaction flow index to assess the local contribution of each patch to overall connectivity, and the betweenness centrality index to assess the centrality of a focal element. These metrics were computed on each graph, and values were averaged to obtain a multi-species indicator of connectivity. In the third step, we prioritized road sections for the creation of new wildlife crossings based on the connectivity gains values obtained for each group. Global connectivity was assessed using the equivalent connectivity index, which combines the measure of habitat amount and connectivity. Each road section, initially considered as an obstacle, was transformed into a favorable element in an iterative process. The connectivity gain values obtained for each species group were normalized to make them comparable and averaged for all species. Once the most important existing structures and road sections were identified, the results were submitted to an engineering consulting agency. This expertise aimed to consider the local context and the technical and land feasibility of the development. Road structures and sections were ranked according to the current ecological functionality of the road, the cost of the works, and the regulatory constraints. Finally, we compared these locations with roadkill data to test the hypothesis that even a partial roadkill dataset can be a good proxy of multi-habitat functional connectivity. Each of the road sections was characterized based on the number of roadkill, the number of existing road structures, the initial landscape connectivity around the section, and the potential gains in connectivity provided by our proposed mitigation measures. The ecological functionality index values were the highest in forest areas. Of the 150 existing road structures with the highest connectivity values, field expertise showed that 41 had a source of disturbance nearby or did not have an appropriate spatial configuration to expect improved connectivity. The expertise was thus focused on 109 road structures. The establishment of cost and technical constraints for their improvement provides information to managers for decision support. For the simulation of new wildlife crossings along a highway, each road section was characterized by the average gain in connectivity for all species combined and separately by species group. Based on these results, managers can choose the strategy to be implemented according to their priorities. Locations that would strongly improve connectivity, even if they only concern a part of the species, for example, in a range for the open habitats, or locations with more limited gains, but that concern all species. And finally, the statistical model showed that the number of roadkill increases with the values of the ecological functionality index and the forest connectivity gains, but in contrast, it decreases with the number of structures on the road section. This suggests that animals can use these structures to cross the highway, thereby reducing the risk of incidents. Our results show that roadkill hotspots are found both in areas with high initial connectivity values and in areas with medium connectivity values and high connectivity gains. This means that it may be effective to implement mitigation measures in areas of moderate connectivity where there is the greatest potential for improved connectivity. This raises questions about studies that rely only on an initial diagnosis of ecological connectivity to locate mitigation measures in high connectivity areas. In our study areas with high connectivity values are mainly composed of forests near the infrastructure. In contrast, areas with high potential gains in connectivity are composed of forest but also crops and grassland. Therefore, it is important to consider landscape connectivity, but it is even more important to consider it diachronically by testing the potential gain of each location in a systematic way. Furthermore, field expertise is essential for model consolidation, both during operational studies and during medium and long-term monitoring to ensure the effectiveness of mitigation measures. This innovative operational-oriented study could be a useful tool to assist the decision-making process of land use planners who want to improve wildlife crossings of major transportation infrastructures. Thank you for your attention.
So she's not online, but I don't know, so for questions it's a bit tricky now because she's not there. But I don't know if you want to discuss a little bit.
attention is now most on the most valuable corridors. What I'm missing is what is the best place looked from the viewpoint of the civil engineer. What is the best place on the roads? Where is it possible on the roads?
Yeah, indeed.
Because that means money. Where it is easier, it's better to do. So I like that there is a kind of analysis of where in the road situation is the best possibility to create a corridor.
I think that after this kind of analysis, you have to really to provide options, as she said, actually, you know, they are also giving options for interventions, because as we know, money are always less, never sufficient, and there is not always the will to invest in this kind of structure. I can talk about Italy, and perhaps my colleagues from Italy know that too. So it's important to give options and to make together, I mean, to the financial investment with the biodiversity results that we have, and also to have also to communicate that to the public, so the people have to support this kind of interventions. Otherwise, this could be seen as wasted money, and it would be even worse for our aims.
Thank you. I'm Nikki. I come from Greece, and I work for a motorway. And we had this, I'm answering your question because we had this problem evaluating which structures of the motorway should be better functioning. And that is happening through the life-safe crossing that we're about to discuss in the afternoon. So we have evaluated out of 150 structures, and we considered 56 of them valuable to be better improved, to be better functioning. So if you would like to hear what we did, you are welcome in the afternoon session for life-safe crossing. Thank you.
Thank you. Thank you for your contribution. Lazarus?
I was thinking just a next step of Hans, not only about engineering, but about species distribution and presence. And having the feedback of Nikki, we would like to say that in Greece we are planned to have some mitigation measures, but we didn't have estimated that the distribution of bears will change on time. And today, as we know that rewilding is reality and distribution of species are changing, and wild boar, Carmen knows very well, that are coming in the city centers. Yeah. So in such a model, in such a prediction, we have to include also parameters that are connected with the species distribution, because these are the elements for permeability.
Also considering the climate crisis, and so species will change, will move. This is something
this is a pair. It's not alone. It's, you know, they are going together.
Yeah, okay, but for other species. Yes, Marita?
Thank you. I don't know if I haven't got it, but I missed the group of insects in that analysis, because we know we have a massive decline, and we have to look for them also, because they're if you look in the food chain, they are very important, so we have to do something for them, and we have to introduce this also in the methods. I know that this is very difficult to do, but we have to have it in mind that there is a need for that.
Yeah, perfectly agree. I mean, there are studies about the connection of butterflies. So there are studies on that, and also the impact on roads. But for other insects, for beetles, yes. Yes, we mainly focus on large animals. Yes, we know, we love them so much, but yeah, we should love also insects. Any other comment? Yes, please.
We can compare it in some cases with the mammals because they transport them. So we have a functional connectivity, and I miss always in these investigations that we don't think about the functional connectivity, but then we have to integrate also the surrounding landscape and the land use, and that makes it much more complicated. Thank you.
Indeed, yes, thank you. There are some questions from the chat, no?
Some comments from Dror.
Can you use the microphone there?
Is it function? Dror, that in my experience, this type of analysis is just the first step to give the decision makers and the engineers the best options. And then further analysis and field work should be made to decide the exact favorable locations. It's regarding also your contributions. And Eric, oh, sorry, I don't know if it is. Eric, the problem with this model is multi-taxa and needs to analyze ecological transparency of thoughts and the potentiality of existing road passages. Few data and studies on these existing passages. Wendy, 100% agree, Eric, okay? So I think these are the last contributions.
Thank you for the contribution.